Thank you for inviting me today. So today I wanted to talk about our project of expert assessment of subsea permafrost carbon stocks and the sensitivity to climate change, and just tell you about the results we found and where we're now. So the things I want to talk about today is I want to talk about a little bit about subsea permafrost and the background of it and why we did this study, and then what did we found from our the experts, and how just generally expert assessment can help us for informing policy. So as already you know, as the sea level rose at the last glacial maximum, the part of the terrestrial permafrost, which contain large stocks of organic carbon, submerged, and now we know that as the subsea permafrost. And so when ever since the subsea permafrost has submerged, it's starting, because of the thermal regime has changed, it's starting to degrading. The degradation of subsea permafrost can have many impacts, as it affects the marine and terrestrial habitat, or it can affect the food chain, but also it can have a feedback to the climate. And that was the focus of our study. Now, even though there's many studies that prove that shows that the subsea permafrost region is having a feedback on the climate now and the future, because the hardship of studying this system and the complexity that it has, there's still many aspects of it that remains unknown, and it's uncertain. Therefore, in all of the climate change regulation policies, we don't see that it's kind of like neglected, or it's not really acknowledged as it should be, the importance of it. So that's why we use expert assessment to just see, well, what is going on in the subsea permafrost, just based on the best available knowledge. So some of you may be familiar with the previous projects that have done for the terrestrial permafrost, and that's something similar that we're doing here. So the overall goal that we had in this study was really to just get a rough idea about what is going to be the feedback of the system to the for the climate change, about the fluxes, and improve its consideration of subsea permafrost in the feedback and subsea permafrost feedback in policy making. The map that you see here is the reference map that we gave to our experts in our survey. That the dark blue here is the combination of the continuous sea shelf permafrost and the discontinuous sea shelf permafrost. We call that in our study the subsea permafrost domain, and we ask our experts to give us their estimates based on this part. So in our survey, we had 12 different questions about the different aspects of the permafrost and different timescales. We wanted to know how it has been changing from the last glacial maximum until the future. So the questions that we asked, we first want to know, well, how did the expert think the area has changed? And then the next group was about the organic carbon stocks that are now there and how they will be affected in the future from climate change, and also the methane stocks. We had two target questions, I will call them, for policymakers, which was like, how will the greenhouse net fluxes about carbon dioxide and methane will change, be in the future, especially under two different RCP scenarios. So this will be the questions that we will go through. So this was an example of a question that we our experts saw. So we first asked them to give us a quantitative estimate for their estimates, and we asked them to provide us with a range. So like their central estimate will be their best estimate, and then where they provide us with a 95% confidence interval. And then we asked them to give us a self-estimate about how confident they feel about their answers, and what is their expertise level. And finally, where did they get this, what is their estimates based on, and what do they think is the largest sources of uncertainty in that area. Okay, so now I'm going to what the expert thought about subsea permafrost. So before I begin, I just want to give a little bit, go through the graphs so you know what each one of the graphs mean, because it will be the same format. So each of these points that we have here, these represent one individual expert. So it shows their central estimate of for that particular question, and the range here is their upper and lower estimates. And the gray lines here is connecting the same individual expert. So you know, like this expert thought about the air will be here, and then for like what they thought for the other question. And then the three black lines, each of them shows the median of the central. So this one will be the median of their central estimates, the median of their upper estimates, and the median of their lower estimates. And of course, where our plots get wider, that means that our experts had more agreement in that particular part. So for the first one, that was area, as you can see, every single expert agreed that the area of the subsea permafrost has degraded, and right now it was actually one of the questions that we had like a pretty good agreement that on the current area, especially, that all of the it's been 2 million square kilometers, that which is compared to the terrestrial permafrost, we can see how smaller it is. It's about, I guess, 1/6 of it. So that takes us to our next group of questions, which was we asked for what is the organic carbon sign, the methane like in and on the continental shelves at this subsea permafrost domain. For the organic carbon stocks, we the central estimate, the median of the central estimate was 400 gigaton carbon, and for the present time it was 300. That shows a decrease in the organic carbon stocks because of the microbial activity that is converting the stocks to greenhouse gases. However, we had 3 experts that you can see here that actually thought there will be an increase in this organic carbon stocks, that they point out this is because of the high rates of terrestrial sedimentation. So, and for the methane stocks, we had a very wide range of estimates, which you see the median central was 67 gigaton carbon, and the range is between 15 to 229. And the experts point that there's a lot of uncertainty with the methane stocks, and this is really because of the how patchy is the observations for the methane stocks. So before we get to our target questions, we ask the experts that, well, how will you think the stocks will be affected just by like the thermal shock, regardless of any kind of scenario? So for the organic matter, our experts generally thought it would not. It will have a very low effect by industry time. So each of these, there was like 5% for the central estimate for the medium one, and then 9% and 30%. So as you see, as we go by time, they think, well, it will increase, but most of people agreed that it shouldn't be like very high for at least the early years. And once we calculate this based on the current way, if the range will be 1.4 to 75 for 2100 and 8.5 to 260 with for 2300. And the same thing for the methane stocks, which they estimate a very low percentage of affection. This is for the different years. And again, if we see how much that will be on gigaton carbon, we can generally see from these graphs that the experts didn't really think the change will be really drastically, but also we can see that the methane, all of them thought that the methane stocks will be less sensitive compared to the organic matter ones. So, so then we get to our net fluxes. We want to see how will this contribute to climate change. So first we had to ask for, well, what is the current their estimate of the net fluxes, to then see how will this change in the future. So the net fluxes was just generally very disparate between all of our the experts. And for the carbon dioxide to the water column, their estimate was 33 megaton carbon, which and then for the methane, it was the median expert here was 13.5. And they all agreed that, well, a lot of it that will be consumed, and just a less point of that, 3.5 of that will be released to the atmosphere. But as you can see here, for the methane, again, we have a really wider range of estimates. That is because all of these uncertainties. So then we asked, well, what do you think it will happen in the future under different climate scenarios for the different RCPs? So this one is for the carbon dioxide net flux, that, as you can see, all of them agreed that, well, in RCP 8.5, there will be a higher emission from this net flux, and this is, but still, and this difference will increase as the years go up. So for 250, it's not like as much as like most of them agree it will be pretty low. For 2100 and to 2300, still a lot of people think it would be low, but then it started to, some people think now it can actually get really higher. And once we again we see how much that will be from based on the current ones, this will be the numbers that we can all see. The RCP 8.5 will be kind of higher than 4.5. And the same thing we had for the methane flux. Again, that again, everybody thought it won't be like a very huge change to even 2100, and the change will be like really noticeable to 2300. And again, when we convert this and compare them to the carbon dioxide, it seems like the methane will have like a less contribution to the overall thing. But once we convert all of this to their carbon dioxide equivalent, we will see that actually the methane fluxes do have slightly a higher contribution to the overall the carbon dioxide equivalent. So the black line here is their cumulative greenhouse gas release from the subsea permafrost, and the green one is the methane and the carbon dioxide share about each of. So at each point, you can see how much share they each have, and this yellow one is just the current. So you just have a reference to see how it changed. So as you can see, with time increase, the overall estimation was for 2300 was 98 gigaton carbon dioxide, and for RCP 8.5 it was 110. But still, when we put the confidence intervals here and we involve those, we would see that actually it can be a very wide range. And this is all because of the uncertainties and like the different experiences that each of our experts had with the system and how they perceive the system. So you can see like for here, for 2300, it can be actually from 24 to like 2050. That is like actually 10 times higher, and it's like it really shows that how much this is uncertainty it is with this system, and how much it can be in high risk for us. So, and overall, my main conclusion from this study was that subsea permafrost, it's according to our experts, it's responding pretty slow. And which it kind of makes sense, because when we think about the numbers from the last glacial maximum until now, that is like 40,000 years, it shouldn't get like really crazy from just 300 years. So that was like what most of our experts thought. But then even if that is it shouldn't be neglected for two main reasons. Even if that's the median thing is right and it is going to respond pretty slow, considering that how small this area is, it's like 0.4% of the whole planet. It's absolutely a hotspot for us, and then we should consider the uncertainties, that what if actually the upper values are right. and these all will show us like there should be a risk frame, and then the more that we can have a more like quantitative estimates, the first order estimates, it will be easier for the policymakers to understand what's happening, and based on that the research can happen and like correct these first generate estimates. So the way, and like all of our experts told us that the main reason that all of these uncertainties is because we don't have enough field observations to support the model. So I think that was the two like maybe take-home message for the policymakers is one, that there can be a high risk if we neglect this, and this should be considered, and it should be like more like supporting for fundings for like field observations and however they can like support the models. And this is really like I want to finish like with here, that this is really how expert assessment can actually help us, that it can just really is a way that connects scientists to policymakers, and it actually can make just the best available science that we have right now, it can make it more visible to policymakers and the public. Thank you all for your time, and I will be happy to answer any questions or any ideas that you have for like how we can improve this study. And we're still we are near to like submitting this, but we are, because like the more experts we have, and right now we have like 23 experts in overall for all of the questions, which each some answer to different question. But the more experts we have, and the more people who have experience with the system can contribute to the system, the more reliable this ranges can get. So if you think about anyone who can actually still participate, we will be happy and to share with them. Thank you.
Thank you very much, Sara. Does anyone have any questions for Sara or comments?
I actually do, but I'm happy to give other people to go first. But otherwise, I was curious, I'm not sure if I missed this. Is it possible to treat anything like an outlier in an expert survey? I saw in some of the graphs you have like the error bar goes up to 1,000%.
Yes.
And I was curious, that looks like an outlier in any other regular analysis, but here it's not treated as anything.
Well, like no, so we don't really treat, we try not to treat those as out, like, well, there are like just a very few of them that was really like really high, and it couldn't just be possibly right. So, and we really think that was just maybe a misunderstanding of the units. But then here we didn't really want to, we didn't want to exclude the outliers. I really want to like make it seem that they can't understand the level of uncertainty in the study, like how high or how low it can be, and the urgent that there should be more field observations to like reduce this range of uncertainties.
So it just makes me wonder a little bit, do you think it's a little too early for an expert assessment on that topic, given that there isn't enough out there?
Well, I think for the other environmental like things that happen, if like this study is especially really good when we do not have enough information, because if we really when we do not have enough information, it's just like our best estimates based on the today available knowledge, and this will improve by time going. But I think it just gives a really rough idea to the policymakers of what is happening, and also for inside of the community that they see what should be the research priorities, and like where part to focus on.
But I mean, sorry to keep going on this, but for that, an expert assessment,
yeah.
I mean, to show that we don't have enough field data to support this,
okay.
A review on the existing data would have been enough, maybe? Whereas there's a lot of opinion that goes into an expert assessment, and I wonder, like I filled out the survey myself, and I know that I did not have all the expertise because, yeah, I mean, I do more terrestrial permafrost.
Yeah. So it's really depending on how these numbers are going to be used. I feel like, so there is like criticism about this method in general that some people just think, and it's think that, well, these are not like reliable, like these are just guesses from people. But I think that really about how these are used ever since expert assessment has been used, especially like in the United States, it have been used from the early 40s. It always was it benefits both sides, the policymakers and the scientists, because this is the only way, is like the quantitative estimates is just the best way to make it more visible to the policymakers. And the more it becomes more visible to the policymaker, the better it will be. And right now you see that our estimates is like really wide ranges, but then each of these experts, they do have a sort of experience with the system. And I think like for this, I think it's just a really good first step to just like have an overall understand of what is going on in the system. If that answers you.
Okay, thank you.
Anybody else have any questions or comments?
Can I, hi, this is Min from Penn State. Can I follow up Christina's question? And I also had a similar thought. I think this is really a very important, very critical study. And just because of the high value of the result, and I just wish to kind of again verify the validity of the outcome. And so when you publish a paper or cite the opinions of the experts, do you show the references from how the expert derived those different data? Because I think it's it's not based on experience but knowledge, or knowledge come from some kind of data or assessment. So there has maybe some kind of published work.
Oh, yes.
If without it, just say people said it, that probably not so convincing.
Yeah. So so yes, for each question, as I show you, we did ask them that how did you generate this data? Especially for the current ones, they all had very certain references that they point us. Yes, we used like this reference, this reference, this reference, and based on the numbers that they have, and based on these, and they actually some of this like send us their calculations that based on like all of the current knowledge that is, and this reference, they're estimating this. However, for the future ones, it was so like. Again, for the current and the past one, most of our experts that their estimations is based on like published things. But for the future one, it was really just a more of their professional opinion, because it's not that much of published. But then it's just really it's between of like sometimes maybe for the future is between like bad and worse. Like worse is like we neglected completely, but bad is will be just have like maybe a wrong idea, but like it's just a like very rough idea about it.
Can I ask a question?
Uh-huh.
I wasn't clear from your 23 different experts, the spatial aspect of their estimate. Like, were there 4 people with estimates for the Barents Shelf and 10 people for the northern coast of Alaska? Or what was the distribution of their estimates in terms of their area and overlap?
Okay, so we we did ask him that like where is like their study region, and we did actually we collected, and it is pretty diverse. Most of them were like working on the United States and the Cyprian, but we did not make a correlation about which one expert, if their area of expertise, how will that correlate to their estimate. I think that's a really good idea, that maybe we will think about that and see if we can like kind of correlate that, see if like the people that are working on a certain place, if they have like a more similar ideas than other people, if I understand correctly. But I think that's a really good point that we can work on.
Well, I just sometimes in the news we hear pretty large numbers coming out of the researchers working along the Russian coast.
Yes.
And so I think it would be really good spatially to know where those estimates come from.
Okay.
And I do think it's really important, because if these higher numbers for the future are real, it has a huge impact on the nationally determined levels that these different countries are going to assess to. And the sooner we get that right, the better, I think. But I have to leave in a few minutes, but I did want to just say I'm currently chair of the Polar Research Board in the Academy, and we're thinking about trying to perhaps have a special workshop or report to bring together people to talk about permafrost, and particularly on terrestrial and the abrupt thaw issues that are coming out. And it's always a really big deal as to what is going on offshore. So the more you can do with your study, the better. And I'm happy to learn more about it here today. So I'll let somebody else ask a question, but I will have to leave in a few minutes. So if you don't see me on, don't take it offensively. I got another meeting at 3 across campus.
Thank you so much.
I just had a quick general question that might be relevant to think about or include in the paper. When you're talking about the projected future change, how is change in sea level considered? So for example, these large coastal plains that exist, for example, in Siberia and Alaska, are likely to be partially inundated in the future. So was that considered, or are you talking about primarily current subsea area in those future estimates?
We're talking about just we just really try to make it as simple as possible. Like, we didn't want to get it too common, but that's like a really good point. But no, we're just really basing on the current one. But we should like think about like how can we actually include that, or at least mention it in sure.
Okay, anybody else have any questions or comments?
Yeah, I have a quick question. Do you also ask, or did you ask any questions about the depth of this deposit? So how deep is this subsea permafrost, or is that not a question?
No, we didn't ask that, and actually that's interesting, because most of our like after that, like most of our experts did point out that the depth of this organic is like one of the main uncertainties. But no, we didn't ask for that.
Okay.
When are you planning to publish this or make a report?
So right now we send this to our co-authors. We have like our finished draft, but then it really we should see like how they will what their opinions should be, but it should be as soon as possible, because we already have everything. We have like a number of co-authors, so we should wait to see what their feedback will be.
Okay, anybody else have any comments or questions? Okay, well, thank you, Sara, so much for presenting the results of this study. And yeah, I think it's a really tough topic because it is very understudied. And yeah, there's some data out there on hotspots, and it'll be good to sort of get a better handle of this in the future. So thanks for letting us know what the state of our knowledge is on this.
Great, thank you for inviting us.